Hey guys, Mr. Ast here. Before we get into Topic 10's lesson, I just got to tell you a story about yesterday. It was at the end of the day, and suddenly I get a text message from my wife. She says, please pick up a carton of milk, and if they have eggs, get me a dozen. So I come home, I do what she asks. I come home, and I put all the groceries out on the table, and she says, why in the world would you buy 12 cartons of milk? And I said, because they had eggs. Get it? Okay. Anyways, we're going to talk about topic 10, which is about solutions. So let's get rolling.
I love vocabulary.
And that is true. I do love vocabulary. And vocabulary is very important in this section here. There's 3 words that you have to be very comfortable and familiar with, and they all start with SOL. So it can sometimes be a bit confusing if you don't spend a little time and, kind of understand which one is which and how they work together. So first of all, a solute is a substance that dissolves in a solution. A solvent is the substance that dissolves the solute in a solution. And a solution is a mixture of solute and solvent together. So, the solute is what's being dissolved in a solution. For instance, the most common solution on Earth that we understand is water. Solvent. Water is an amazing solvent. It dissolves polar things quite well. Our blood is a solution, which is a mixture. Our blood is a solution where water is the solvent, and there's many different solutes in it. And because water is such a good solvent, it can carry all these different things around in your body easily through the solution that water is. There's a lot of solutions out there. A lot of times people don't realize it, but the things around you, everything you drink pretty much is a solution, and water is the solvent, whether it's milk, apple juice, orange juice, even alcoholic beverages. It's mostly water that's the solvent, and then there's solute things in there, whether it be sugars or colorings, different types of flavorings, and alcohols. Ethanol would be a solute in the solvent, which is water. So these make up solutions. For instance, you guys hopefully have seen this pretty cool little reaction. If you put Alka-Seltzer in water, it dissolves. And if you were to put Alka-Seltzer in water, the Alka-Seltzer would be the solute because it's dissolving in the solution. Water would be your solvent. And once it's all dissolved and you drink it to make your tummy feel better, that would be a solution, which is made up of the Alka-Seltzer and the water. Okay. So with this concept of solute, solvent, and solution, you're going to need that vocabulary to do things where you see solutions that are put in percentages. You often see this at stores, grocery stores. When you buy commercial products, they'll say it's a percentage of something in your solution. You buy a solution of something, you see percentage, such as like let's use ethanol and water. Wine is about 10%, roughly 10% alcohol. So on wines, drier wines, you'll have a higher percentage, and sweeter wines, you have a lower percentage of alcohol in it. So that percentage in a wine is how much ethanol there is in the solution. So you see these percentages quite often with things that we buy commercially. So what that means, it's by mass. So a 5% solution of sodium chloride, we're talking about salt water here. A 5% solution of salt water, which would be sodium chloride dissolved in it, is made by dissolving 5 grams of sodium chloride in 95 grams of water. So if I wanted to make a 5% solution, I would do so by putting 5 grams of salt and mixing it with 95 grams of water. And it would look a little something like this. But again, our solute is sodium chloride. And if we're going to write this out mathematically, it would look something like this. We have 5 grams, that's our solute, divided by our whole solution. And what a lot of people kind of confuse about this is they go like, well, why not just why shouldn't we have 100 grams of water? Because the solution is made up of the solvent and the solute. The solution is both solute and solvent. So if we add the solute, which is 5 grams, to the solvent, which is 95 grams, our solution is 100 grams. So to figure this out, or to look at this mathematically, the solute is divided by the whole solution, and again, the solution is made up of everything, the solute and the solvent. It's the whole thing together. And that would be the same as saying that it's the percent of the solution over always 100%. So these numbers are nice and easy so that we can kind of illustrate this, and then these numbers here are more realistic of, so these numbers are your percentages. So let's do some practice problems here. If you think you understand what I said, and even if you don't, I'd like you to pause the video here and try these before you continue, and I'm going to work these things out right now, and we'll see if you match what I got. So please do me a favor, pause the video. You will need a calculator, you will need a periodic table, but pause your video right now and give these a try. And hopefully you've done that. And now let's try to work these out together. So number one we have, sorry about here, we've got 0.23 grams of sodium chloride, which that would be our solute. 2.3 grams of solute divided by our 5.0 grams, and it said solution. And that would be equal to X, and I want to know the percentage, the percent composition over 100%. So I'm going to set it up this way for the first time here, but if we take a look and we cross multiply, I'm going to just bring that 100 over here. So it would say 0.23 grams over 5.0 grams times 100 equals, so let's try that out real quick. We'll say 0.23 divided by 5 times 100 equals, and I have got 4.6%. By the way, it's a percent there. Grams cancel. We're in percentage. Okay? Okay, let's look at number 2. So I changed markers. I like this one. Looks good. If it's not too much space, I can use this one because it's kind of thick. But anyways, so number 2 is 0.210 moles of sodium bromide, and I need to convert these moles into mass because percent composition is by mass. So we're going to have to do some stuff off the periodic table. For every 1 mole of sodium bromide, what's the molar mass of sodium bromide? Okay, well, to figure that out, we're going to have to add up a sodium, which is 22.990, that's a sodium, plus a bromine, which is over here. That would be 79.904. Add those two together, and we have the molar mass of a sodium and a bromine, which is for sodium bromide, which would be 102.894 grams of sodium bromide. Let's add those, or multiply that together. So I'm going to take this number and multiply it. So let's multiply this number by 0.210, and we get the moles of sodium our mass of sodium bromide would be 21.608. I'm just going to go round off it there. 608 grams, and that's my solute. That's what's dissolving. Solute over, and the question says we've got 224.7 grams, and that's my solution. And I'm going to multiply that by 100. So let's take our answer and divide it by 224.7. And then I'm going to multiply that by 100. And I come up with proper significant figures, 9.62%. That the 6 rounds that 1 up to a 2 with 3 significant figures. So that would be the answer to number 2. Okay. Okay, let's take a look at number 3 now. I got interrupted. Class started, so this is actually another day. This is a 2-day lesson. My gosh, it's taking forever, guys. So anyways, let's take a look at number 3 and set this one up, hopefully, like I said, that you have given it a shot. In number 3, you have, where we got here? In number 3, you have 0.07924 moles of lithium fluoride. Well, this percent composition is a mass-to-mass relationship. It is not a molar relationship. So we got to convert this into grams. And we know for every 1 mole of lithium fluoride, so that is, don't worry about that. For every 1 mole of lithium fluoride, we're going to use our molar mass to convert that into grams. So lithium fluoride has, you're going to add a lithium and a fluorine, so 6.941 plus the fluorine, which is right here, 18.998 equals, so my molar mass of lithium fluoride is 25.939 grams per mole. And again, that's just a mistake there. Okay, don't worry about that part. All right, so let's calculate that. So we're going to take our number, our 25.939, the molar mass, and we're going to multiply that by 0.07924. And so when we multiply these two things together, we come up with 2.0554, we'll just stop there, grams. And the lithium fluoride, remember moles cancel with moles, the lithium fluoride is the solute, so that's what's dissolving in the water, our solution. So that's our solute. Now we're going to divide that by the solution, but take a look. This question can trick you, because not like in 1 and 2 I told you what the solutions were. In number 3 I told you the mass of the solvent. So there's a little extra work here, because the solution is the mass of both the solute and the solvent together. So our denominator would be 2.0554 grams, which again is solute, plus the 7.17 grams, which is the solvent. Together, the solute and solvent, that makes a solution. I'm going to multiply that by 100. We get our answer here. So let's do the denominator first. So I already have this number entered in my calculator for the 2.0554, and I'm going to add to that. From the question, it told us that we have 7.17 grams of solvent. So we're going to add 7.17 grams of solvent to that. So our solution is 9.2254 grams. That's our solution, and that's going to be our solvent. So we're going to take these two numbers and divide it. So 2.0554 divided by 9.2254 equals this, and then we're going to multiply that by 100. We're going to multiply that by 100, so times 100 equals this number here. So when we do all this, we come up with 22. In my original question, I had 3 significant figures. There's 4 in this number, but there's 3 in this one. So I'm going to make sure I answer it with 3 significant figures. So 22, and our calculus says this number over here. So I'm going to round the 7, we'll round that 3 up. So 22.3%. That is the percent concentration for number 3. There we go. All that work there. Okay, let's move on to number 4. So with number 4, it's just a lot like number 3. We've got moles of our solute and grams of our solvent. So let's give this a shot. So number 4 should have been solved something like this. All right, number 4 would be the same setup as the last one. 0.03020 moles of sodium fluoride times the molar mass of sodium fluoride. We got to get those moles into grams. So our molar mass of sodium fluoride would be 22. The sodium 22.990 plus the fluoride, which is over here, 18. It's over there. It's kind of hard to see. It's a little blurry on yours, but hopefully you have a periodic table and you're doing this. 18.998. So this is our molar mass of sodium fluoride. It's just 1 sodium and 1 fluorine. 41.988 grams of sodium fluoride for every 1 mole of sodium fluoride. So we have this number here, and we're going to multiply that by the 0.03020. Multiply that. Oops, didn't you multiply? But anyways, that's what it equals. So we have a that is 1.2680. I'm just going to round it there. 4 grams. Notice I bring it out a long ways. I don't want to round off during my calculations. I can get some mistakes in my final answer. So I did round, but I did use a lot more numbers than I'm going to answer in my question. I'm going to be using 4 significant figures in my question, and I use 6 here, and that's a good thing. And that again is my solute. I'm going to divide that by my solution, which would be 1.26804 grams, plus my solution, which is 360.8 grams. This is my solute, and this is my solvent, and together they are my solution. So we're going to add these 2 up together. So let's clear this because I think I put a times there. So we're going to add those up together. 1.26804 plus 360.8. That would be 362.068 times 100. So let's just calculate that out. 1.26804 divided by 362.068 times 100 equals, this is a very small number, percentage. So there's not much solute in this. It's very much just water. So it's only 0.35, and our question has 4 significant figures. So 0.3502. There's our 4 significant figures. Maybe remember, leading zeros never count. Percent. That would be our percent composition in number 4. Number 5 is a bit more challenging than I even wrote. More challenging. It's a little more challenging because here you're trying to figure out, it's a lot more realistic too. As a chemist, we sometimes have to create solutions, and if I need a solution that is 73.5 grams and I want that solution to be 13.5%, how can I make this solution? Sodium hydroxide is normally a solid, but I'm going to put it in water to make it aqueous, and I want only 13.5% of the solution to be sodium hydroxide, the rest of it to be water. So how could I make this solution? So when you do number 5, you may not understand where to start, so just write down things that you know. You know that 73.5 grams is the mass of the solution. It says I need 73.5 grams of the solution. So that's my solution. And I always say write stuff down if you're not sure where to start. Just at least write it down. And I also know that my solution is going to be 13.5% sodium hydroxide. How can I make this solution? Well, I need to know how much solute to add, and I need to know how much solvent to add, how much water. So I need to know these things. I also know that's the first thing I would recommend doing is, what do you know? The first thing is, what do you know? The second thing you should do is, what kind of, this is what you know from the question, what do you know from experience? What do you know from science, math, whatever it is? What tools do you know? Well, we know that it is solute over solution equals your percentage of composition over 100%. So that was what we talked about when this all started. So that's kind of your setup. And if you notice, well, I know my solution. I know my percentage. If I can solve for my solute, I got one part of the puzzle solved. So let's do that. So our solute, I'm going to say, is X over 73.5 grams equals 13.5% over 100%. Okay, we'll cross multiply. That would make, if I bring this one up here, then it would say times 73.5 grams. Get rid of that. The percentages cancel out with each other. So to solve this here, I would say that that is 13.5 times 73.5 divided by 100. So this is telling me that my X and my solute would be 9.92 grams of my solute of NaOH. So to make this solution, I would need to measure out 9.92 grams of sodium hydroxide. But what else do I need to do? Well, that part's not as difficult, but don't forget about it. If my solution is I want my solution to be 73.5 grams of solution, and I know 9.92 grams of it is sodium hydroxide. You could do it one. Well, then what you would do is get this much sodium hydroxide and the difference here. So you take 73.5 grams minus the 9.92 grams to make up the difference there. So 73.5 minus 9.92, that'd be 63.58 grams of water. Because remember that the water plus the sodium hydroxide will be the total mass of the solution. And if the total mass of the solution needs to be 73.5 grams, then I can say 73.5 grams, the solution minus the solute equals the solvent. So the answer to this question would be, I would take 9.92 grams of sodium hydroxide and 63.58 grams of water, put those together, and that would create a 73.5 gram solution that is 13.5% sodium hydroxide. I hope that made sense, and let me know what you think, and I'll talk to you guys soon.